Types of chemical bonds that we're going to talk about. They are covalent bonds and ionic bonds. Ionic bonds is where an electron from one atom gets transferred to a different atom. So one atom takes an electron from another. Covalent bonds are ones where the atoms share electrons equally. Okay, so you can see in this diagram that they're being shared between the two. And that's just a funny little cartoon about ions and transferring electrons in ionic bonds. Okay, in this slide, what we're talking about are electrons. Electrons, the basic rule for electrons, we know that from Bohr's model that you have the nucleus of an atom in the middle. That's where all your protons and your neutrons are. And then around the outside, we start filling up the electrons. Where exactly those electrons are is what we're going to talk about in the next few pages, in this page of your notes. The basic principle is that electrons always want to occupy the lowest energy level possible. And in an activity that we're going to do called Hogg-Hilton, we'll go over all of these rules and about how electrons fill up that space around the atom, where they, I guess, quote unquote, you'd say where they live in the atom, okay? But the basic thing is that you fill up the lowest ones first. So this is the order of how the shells around the nucleus. So the first shell would be your 1s, and then you'd move up to 2 and 3 and 4 and so on. Then your electrons are going to go in the 1s first, then they would move up, so they're going to go here first, then they would move up to the 2s, then they move up to the 2p, then the 3s, 3p, 4s, 3D, 4P, 5S, 4D. Now, don't worry about where the P's and the D's came from necessarily. It's just the name of that energy level, 1S. When you get into chemistry in 10th grade, they'll explain exactly where the S and the P and the D and the F and all that comes from. Right now, all you need to know is that you fill up the first level first, and then you move on up. Each one of these blanks can hold 2 electrons. Each blank holds 2 electrons. And that'll be part of the activity that we do tomorrow. Okay, here's just another diagram for how you can remember, possibly how you can remember how they fill up. It's called the Aufbau principle. The Aufbau principle says that you fill the lowest levels first. Okay, and then we move up to the higher levels. So that means we fill the 1s, and then we come around and we fill the 2s. Then we come around and we fill the 2p and the 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and so on and so on, okay? And again, that's just the levels of where these electrons live around the outside of the atom. Which orbital are they in? There are 2 ways to write electron configuration. Electron configuration just means it's telling you where the electron is in the atom. What orbital is it in? What shell is it in? Where specifically in the orbital, and so on. And there are 2 different ways that we can do that. We can do it with what's called the SPDF notation, where it would be something like this, 1s, 2, where this tells you the orbital, or I'm sorry, let me rewrite that. This tells you the energy level. This tells you the subshell within that energy level, and that tells you the number of electrons in that subshell. Then there's the orbital box notation. So this is the 1s orbital, okay, with the line above it. You would put an arrow up and an arrow down. If you have 2 electrons, okay, arrows represent the electrons. And if you have 2 in that subshell, you have to put them going in opposite directions. Again, we'll refer back to our activity on tomorrow to kind of get an idea of why you have to have them going opposite directions. Okay? So those are just 2 different ways of writing the same thing. This tells me that here's my nucleus, here's my first energy level, the 1s level, and inside that 1s level I have 2 electrons. Both of those are ways of writing that there's 2 electrons in the first main energy level. And I give you in your notes, I give you that table that tells you how many electrons can go in each sublevel. How many can go in an S, how many can go in a P, a D, an F. And the best thing for that is just to memorize how many can go in each one. That table also tells you to find those different subshells on. So here's some examples. Hydrogen, we know, has 1 electron. So I put that 1 electron goes in the lowest energy level, which is the 1s level. And that gives me a configuration of 1s1, or a box notation like this. Helium has 2 electrons. So I do 1 up and 1 down to show that there's 2 electrons in the same box. Or I say 1s2. Lithium has 3. That's 1, 2, 3. Now if you notice, that third electron here is going in the second level. 1s2 and then 2s1. So it would look something like this if I were to draw the Bohr model of it. You would have 1 level here with your 2 electrons. Then we'd have another level here with my 2s1. Okay, beryllium has 4, so I put in 1, 2, 3, 4. Boron has 5, 1, 2, 3, 4, 5. Notice that that 5th one goes into the next energy level, which is the 2p. So it would be 2p1. Okay, the octet rule. This is an extremely important rule to remember. Very, 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 very important rule. Atoms will always gain, lose, or share electrons so that they can have 8 valence electrons. Remember, valence electrons are the ones in the outermost energy level. So you want all atoms or all elements want to get 8. There are 2 exceptions to that rule, except hydrogen and helium, and they only want to get 2 electrons in their outermost energy level. Okay. So we talked about valence electrons. Again, valence electrons are found in the outermost energy level. So here's an example, 1, 2, 3, 4, 5, 6 electrons, but there are 4 valence electrons because these are the ones in the outermost energy levels. Valence electrons, like we had said earlier, are always found in, you can know the valence electrons by looking at what column of the periodic table something is in. Everything in the first column has 1 valence electron. Everything in the second has 2. The third has 3. The 4th column has 4. The 5th column has 5. 6th column 6. 7th column 7. 8th column 8, except this one, and this is helium. Remember, helium is our exception to the octet rule. It only has 2. And you cannot do that with these these elements here in the middle. That rule does not apply as far as the rule of the group number is the valence number of valence electrons. That rule doesn't apply for things in the middle, the transition elements. These are what we call the transition elements. And the lanthanides and actinides. So on those, you can't know the number of valence electrons in their outermost shell just by looking at the periodic table. So here's some more examples. Lithium, again, has 3 electrons, so it has 1 valence electron. It has 1 dot, electron dot diagram, and we've done these before. So this has 2, beryllium has 2 in its outer shell. It has 2 dots, that's 2 valence electrons. Boron has 3, so it gets 3 dots. Carbon has 4, so it gets 4 dots. And the placement of the dots, I'm not, there is an order to it, but I'm not real concerned with you learning that order right now, as long as you know